Alright, this classification, that is linearity of the differential equations. Again, all my examples will fall under the ordinary differential equations, so you take note of the examples here. Now, to look at linearity as a classification, there are rules you must follow. 3 simple rules. I use the word simple because they are indeed simple. The first rule is such that it says the unknown and its derivative must be of degree 1. You must satisfy this condition. Look at the case here. We are looking at both the unknown and then the derivatives, not just the derivatives as we did for the other. By linearity, we consider the unknown function as well. They must be of degree 1. Again, the unknown function and its derivative should not be a product of each other. We don't want to have any product of these. Example, I have y prime or y prime prime. This is the unknown function and its derivative, and there's a product among them or between them. We don't expect that. The third thing is that the same unknown function and then derivative, we don't want to have any transcendental function of them. In the previous video, we went through the transcendental functions, that is the trig, the cos, the sine, the exponentials, the logarithms, and so forth and so on. We don't want to have trig of y prime, trig of y. I'm using y's here to make it simple, but note that we don't just use y and x, but it makes the work easier to understand. Okay, so you take note of these things. If one of them is violated, it becomes nonlinear. So I'll use green here. Any violation becomes nonlinear. So you don't just check one and then leave the others. You must ensure that all 3 are satisfied to say that it is indeed linear, else non-linear. So the same examples we went through in the order and degree, we'll just classify the next thing as linearity or not. So example 1, I see degree 1. All the terms, this is of degree 1. If I take a circle bracket is 1, this is also 1. It is of degree 1, fine, but I have to go back and check the other 2. It says, is there any product between the derivative and the unknown? No. Is there any transcendental function? No. So I'm going to say that yes, this is linear. Okay. Example 2, the degree here is 1. The degree on this is 1. The degree here is also 1. So the first rule is check the second rule. Any product, no. Transcendental functions, no. Hence, it is linear. Example 3, I had degree as 1, confirmed. The second rule, is there any product? No product, but I see a transcendental function here of the unknown function. Hence, this is nonlinear. You realize that one of the rules is violated. Hence, nonlinear. Okay. Example 4, I have degree here of 1. The degree here is also 1. Accepted. Is there any product? Yes. If I expand this function here, I have it as 1 minus y prime plus 2y equal to 0. Because of the product here, this becomes nonlinear. Then the last example, I have degree 1. There's no product, there's no transcendental function, hence it is linear. And so it is interesting to take note of all the 3 rules before you conclude that your equation is linear or it is non-linear. Okay. Alright, so that is it for just linearity of differential equations. I hope it has been helpful. I'll take the last classification, that is on whether the equation is homogeneous or not. And I'm going to use the same example to help you through. Alright, so thank you very much.